There is a powerful force hiding underground where tectonic plates meet, and one forces another under it. This happens in the Pacific and Indian Oceans. Strain builds over centuries. The tension is unbearable until the megathrust awakens. The Earth shakes with a magnitude that can exceed 9 points, more powerful than any other earthquake. When the seafloor suddenly gets pushed up fast, it sends a huge ripple across the water, and a tsunami of huge force is out. These waves are called teletsunamis, and they cross entire ocean basins, ready to take over coastlines thousands of miles away. The thrust fault stretches over 600 miles. The Earth is not just shaking, it feels like it's tearing apart. This is the power of a megathrust earthquake. Those caught in its path will have to fight for their lives. Japanese authorities recently had to issue their first ever megaquake advisory. It happened because of a strong tremor on the edge of the Nankai trough ocean floor zone. In the end, most of the warnings were lifted, and there wasn't much damage from the 7.1 magnitude earthquake. Parts of southwestern Japan started to shake, and the superfast trains in Japan slowed down to stay safe, which made travel slower for everyone. But everyone is staying alert as they know about the risk of a megathrust earthquake that could happen within the next few decades in the Nankai Trough. The tectonic plate under the Philippine Sea is slowly sliding underneath the land where Japan is, moving just a few inches every year. The last big earthquakes from this area happened in 1944 and 1946, both with a magnitude of 8.1. These quakes have caused a lot of destruction in the country. The next megathrust earthquake in the region, if it does happen, could be between a magnitude 8 and 9. Scientists still can't agree on how likely this mega-earthquake is to happen, but it could be up to 80% certainty. On the other side of the Pacific, scientists from the U.S. Geological Survey have studied a dangerous area along the U.S. West Coast. It's called the Cascadia Subduction Zone, and it stretches from northern California to northern Vancouver Island in Canada. Over the past 14,200 years, there have likely been at least 30 big earthquakes in this region. One major quake happens every 500 years on average. But for a long time now, Cascadia has been quiet, and it worries scientists. They think this might be because the area is locked, meaning the tectonic plates are stuck together and building up a lot of pressure. Eventually, the part of the seafloor could suddenly break and move by several feet. The shaking would be just 5 minutes, but it would create a powerful tsunami as the seafloor shifts that would last for 10 hours. If it happens, it's going to be the worst natural disaster in the country's history, according to experts. The ground on some inland hills could turn into something like quicksand. This would cause the hillsides to slide and crumble, taking down roads and bridges. Around 620,000 buildings could be badly damaged or even collapse, including about 100 hospitals and 2,000 schools. People in Washington state might have to take care of themselves without help for 2 weeks, finding food, water, and shelter on their own. Scientists are studying slow slip events, where the tectonic plates move very slowly over weeks or months, releasing some energy but not enough to stop a big one. Every time the magnitude of an earthquake goes up by just one number, the energy it releases is 40 times bigger. So we'd need about 1 million small earthquakes every day for 500 years straight to release the same energy as one huge magnitude 9 earthquake. But these small earthquakes might be clues that a bigger earthquake is coming. To better monitor the Cascadia Fault, experts are mapping the fault more accurately and adding better monitoring tools offshore. Scientists receive over $10 million to install seismic sensors and seafloor pressure gauges on a fiber optic cable off the coast of Oregon. The goal is to be ready to warn people and potentially save lives when a big earthquake strikes. A sharp megathrust earthquake happened in this part of the world in 1964. It went down in history as the Great Alaska Earthquake and had a magnitude of 9.2. It lasted for more than 4 minutes, making it the most powerful earthquake in the history of the U.S. and North America. The ground shook so hard that it caused huge cracks and landslides. In Anchorage, many houses, buildings, and roads were destroyed because they weren't built to handle such a big earthquake. In some places, the land was permanently changed. For example, the coastline near Kodiak and Hinchinbrook Island was lifted by 30 feet. In other areas, like Gurwood and Portage, the ground sank by 8 feet. They had to rebuild roads higher so they wouldn't be flooded by the tide. A huge 27-foot tsunami wiped out the entire village of Chiniga. Many coastal towns were heavily damaged, not just by the earthquake, but also by tsunamis and the fires that followed. After the main earthquake, there were thousands of smaller aftershocks for months. A moderate earthquake of magnitude 4.4 shook Los Angeles in August 2024. Once it was over, the LA Fire Department checked around the city and didn't find any major damage or anyone hurt. In the nearby city of Pasadena, which is close to the earthquake's epicenter, a water pipe burst inside City Hall and everyone had to leave the building. Thankfully, there was no danger of a tsunami. The best we can do to avoid panic in such situations is to be prepared. Japan is one of the places on Earth where earthquakes happen the most because it sits on the edges of 4 tectonic plates. Around 1,500 of these earthquakes each year are noticeable. Because of this, the people in Japan have learned to live with earthquakes. The 1950 law set a rule that buildings should be able to handle earthquakes up to a magnitude 7 without falling apart. An update 30 years later said that buildings should only have minor damage in such earthquakes and still work as usual. But if an earthquake is even stronger, the law says the building's main job is to not collapse and save people's lives. At the most basic level, buildings are made stronger with thicker beams, pillars, and walls so they can handle shaking better. Another technique is placing special pads made from materials like rubber at the base of a building. Some buildings are even built on thick layers of padding that separate them from the ground completely, which helps protect them during an earthquake. A skyscraper might sway back and forth a lot, moving up to 5 feet. To stop it from getting damaged, engineers can add something called dampers every second floor all the way to the top. These dampers are like giant bicycle pumps, but instead of air, they're filled with liquid. When the building shakes, the dampers push against the liquid inside them. Even though the liquid doesn't squish very much, it can still absorb some of the shaking. When they're building tall skyscrapers, engineers try to make the structure as simple and balanced as possible. This means having each floor the same height and placing the support columns evenly. But sometimes, architects who design skyscrapers don't want to make these compromises because they have creative ideas for how the building should look. Then they have to find compromise solutions. For example, Tokyo's Skytree Tower, one of the tallest buildings in the world, is designed in a futuristic style but also includes special features to protect it from earthquakes. It has a central pillar, like in traditional Japanese pagodas, and seismic dampers that help absorb the energy from an earthquake, keeping the building safe.
On January 26, 1700, one of the biggest earthquakes in history hit off the coast of the United States. It had a magnitude of 9, which puts it in the top 10 most powerful earthquakes ever recorded. This earthquake triggered a huge tsunami and changed the coastline all the way from southern British Columbia down to northern California forever. Back then, the area wasn't very populated, but thanks to some clever research, scientists figured out exactly what happened that day by looking at old geological records, tree rings, and even some history from Japan. On the same day as the earthquake, a massive tsunami also hit Japan's eastern coast. For a long time, no one connected the two, but in the 1980s and 90s, researchers realized the tsunami in Japan had been caused by the earthquake in the Pacific Northwest. They were also able to pinpoint the exact day, January 26, 1700. They even found old trees in coastal Washington that had all perished around the winter of 1700, which matched up perfectly with the timing of the earthquake. The earthquake came from the Cascadia Subduction Zone, a fault where the Juan de Fuca plate slides under the North American plate. This fault stretches about 700 miles, from northern Vancouver Island in British Columbia to Cape Mendocino in California. The pressure from the moving plates builds up over time, and eventually, another big, devastating earthquake will hit the same region. It's just a matter of time. By looking at the geological records, past tsunami deposits, and signs of land level changes, scientists can figure out how often these huge earthquakes happen. Emergency planners have been preparing for the next big quake, often calling it the big one. Scientists believe earthquakes in the Cascadia Subduction Zone happen every 200 to 1,000 years. And since the last major one was over 300 years ago, the Pacific Northwest is definitely due for another. When it happens, the earthquake is expected to be as big as the one from 1700. But this time, it'll affect around 15 million people. The devastation will be severe. Buildings will collapse, roads and runways will crack, and bridges will fall. Communication in and out of the area will be cut off. But the worst part? The earthquake will trigger a massive tsunami that might hit parts of the Washington coast in as little as 10 minutes. It's not a matter of if, but when the Cascadia Subduction Zone will break. When it happens, it will be the worst disaster the US has ever faced. Worse than the Hurricane Katrina or Superstorm Sandy. It'll impact an enormous area, stretching from southern British Columbia all the way down through Oregon to northern California. That means millions and millions of people will be affected. Fairchild is considered a backup staging area for handling the aftermath of the earthquake, with Grant County International Airport in Moses Lake being the main one. For those who will survive the initial quake and tsunami, the aftermath could be just as disastrous. Aftershocks will follow, and transportation will be a mess. Roads will be damaged or completely blocked, airports will shut down, and most of the main routes, like Interstate 5, will have bridges destroyed. This means food and water supplies will be cut off, and it will be incredibly difficult for help to get in or for people to escape. Gas pipelines will most likely be damaged too, and restoring them could take anywhere from a few days inland to weeks or even months along the coast. Power outages will be widespread within 100 miles of the coast throughout the entire Pacific Northwest. And water could be out for 3 to 7 months. Even telecommunications will be down for 2 to 3 months across the Pacific Northwest, Alaska, and even parts of East Asia. The good news for eastern Washington is that it will mostly avoid the worst of it, thanks to natural barriers between the west and east sides of the state. The tsunami may hit the Columbia River Gorge, but it will lose energy quickly because of a sandbar under the river. The Cascade Mountains will absorb much of the earthquake's impact, so the east side won't feel it as strongly. And since eastern Washington won't get hit as hard, it'll be up to them to handle the aftermath of the quake. That means helping western Washington, taking in refugees from the areas that got destroyed, and delivering supplies to where they're needed. Scientists have looked at other major 8.0 to 9.0 magnitude earthquakes like the ones in Chile in 1960, Alaska in 1964, and Sumatra in 2004, and Japan in 2011. These kinds of quakes can shake the ground for anywhere between 6 to 10 minutes, and that's a long time for the ground to be shaking. Such quakes are super intense because they happen close to Earth's surface, so it's not just a quick shake. It's a long, strong one that can cause a lot of damage. If the Cascadia earthquake and tsunami were to hit tomorrow, over 13,800 people could lose their lives, and about 107,000 people could be injured. The economic toll in Washington, Oregon, and California could top 70 billion. To put that into perspective, we can compare these numbers with some other major earthquakes. In Chile's 1960 earthquake, about 1,650 people lost their lives. The 1964 Alaska quake resulted in around 140 lives lost. The 2004 Sumatra earthquake and tsunami took the lives of an estimated 280,000 people. And the 2011 Japan earthquake and tsunami caused over 20,000 casualties. Authorities know about the dangers of the Cascadia Fault, but even with all the planning, no one can say for sure what will be needed when the big quake hits. Right after the earthquake and tsunami, the areas outside the immediate disaster zone won't be able to help much because roads and airports will be destroyed, and resources will be limited. How can we deal with this kind of disaster and its effects? We don't have all the answers yet. Right now, let's focus on the Cascadia Subduction Zone. It's a huge fault line that stretches about 620 miles from Vancouver Island to Cape Mendocino in California, sitting about 93 miles off the coast. It's like one tectonic plate is slowly sliding under another. When the plates are close to the surface, about 18 miles deep or less, they get stuck because of friction, kind of like pushing two rocks together. Over time, this creates a lot of pressure. When the pressure finally becomes too much, the plates slip, causing a massive earthquake. This is called a mega-thrust earthquake, and it can be huge. Below the area where the plates are stuck, there's a zone where the plates move really slowly. We're talking about just a few inches every few months. This slow movement helps to release some of the pressure, but it also builds up more pressure on the parts of the fault that are still stuck. This means that over time, it increases the chances of a huge earthquake happening. These massive quakes, called Great Subduction Zone earthquakes, can be stronger than magnitude 8.5. Megathrust earthquakes are the biggest earthquakes that happen. They can go over a magnitude of 9.0, which is insanely powerful. Just to put it in perspective, a magnitude 9.0 earthquake releases 1,000 times more energy than a 7.0 and 1,000,000 times more energy than a 5.0. These earthquakes happen when a lot of pressure builds up in a part of the fault that's locked, which means the plate can't move past each other. When that pressure gets too high, the fault finally ruptures, releasing all that built-up energy in one massive shake. The Cascadia Subduction Zone is super long. That's why if it were to rupture all at once, it could produce a large earthquake. Scientists have studied this region and found that about 18 miles below the surface, the fault is completely locked. The plates there aren't sliding past each other. But deeper down, the plates start to slide more smoothly, causing less friction. This is important because it tells us how much stress is building up in that locked zone, and how it could eventually lead to a major earthquake.
Hey, do you believe in folklore telltale signs that can help predict the weather? Actually, many of them even have a scientific backup. So let's dive in. You've probably heard this one at least once. Red sky at night, sailor's delight. Red sky in the morning, sailor's warning. Oh, you haven't? Then you might have heard a variation with the word shepherd instead of sailor. This weather lore was even commemorated by William Shakespeare, I call him Bill, back in 1593. He wrote a poem, Venus and Adonis, and there is a description of the red sky lore. Turns out Bill was right, and this one can be explained. The red sky appears when dust and small particles are trapped in the atmosphere by high pressure. When sunlight passes through the Earth's atmosphere, it splits into different colors of the spectrum and creates colorful skies. If there's a high-pressure system, it can trap dust and vapor in the atmosphere, causing blue light to scatter and leaving only red. So it can indicate that the weather will be clear and calm the next day, whereas a red sky in the morning can indicate a storm is on the way. How about another one with sailors? Rainbow in the morning gives you fair warning. Rainbow at night is a sailor's delight. Now this suggests that if you see a rainbow in the morning, it means that rain is on the way. However, if you see a rainbow at night, it means that the weather will be calm and clear the following day. And the pot of gold at the end of the rainbow is still a myth. Next one. They say no weather is ill if the wind be still. This one's pretty logical too. Calm weather conditions show us that the pressure is high in this area. Highs are regions of descending air, and they prevent bad weather phenomena, such as clouds and precipitation, from forming. But there's more to that. Actually, calm conditions may be a true sign that bad weather's on the way. We often call it the calm before the storm. Have you ever seen this halo around the sun or moon? Well, it's another telltale weather sign. Next time you spot such a halo, make sure to grab an umbrella before you leave the house. This phenomenon occurs because of refraction. The sun and moon provide light, although in different ways, and this light gets refracted by ice crystals at high altitudes. When you see a halo, it means that the moisture up there is going down. Also, these halos may evolve into another beautiful phenomenon, milk sky. The milk sky is still clear, but the typical blue shade is sort of washed away and appears a bit faded or milky. Today, we can just check the weather forecast on our iPhones. But centuries ago, people needed to have some alternatives to be able to predict the weather. The very first weather forecasts appeared around 650 BCE. Back then, the Babylonians would predict weather using cloud patterns. Ooh, that's a fluffy one. Uh-oh, there's a dark one. We should go inside. People had to wait for quite a lot of centuries for mass weather forecasting. The first prototype of what we have today appeared in 1835, and it was thanks to the invention of the electric telegraph. By the way, back in the olden days, animals contributed a lot to weather forecasting. Some traditions are preserved up to today. For instance, Groundhog Day. Long story short, if the groundhog gets out of its den on the 2nd of February in Punxsutawney, Pennsylvania, and sees its shadow, it will go back into the den, and the winter will last for 6 more weeks. On the contrary, if the groundhog does not see its shadow and doesn't get scared, spring will arrive soon this year. There's no actual scientific backup to this tradition, but surprisingly, in most cases, the groundhog predictions come true. Well, in the US, people get predictions from groundhogs. In Croatia and Serbia, people use bears to see if spring's on the way. On the 15th of February, they watch a bear awaken from winter dormancy. It's all about the shadow again. If the bear gets confused when he sees his shadow, it will go back to its den and sleep for 40 more days, thus prolonging the winter. But if it's cloudy on this day, it's a true sign that spring is coming. As to the poor schmuck who has chosen to wake the bear up, I think I'd pass on that honor. Unlike groundhogs and bears, seagulls can help predict bad weather all year round. They say, "Seagull, seagull, sit on the sand. It's never good weather when you're on the land." These birdies tend to sleep on the water, so if they sense turbulent wind, they prefer not to struggle with it but avoid it. Therefore, they just land on the beach and wait. Smart! Rain before 7, clear by 11. Pretty common, but only partly true. The occurrence of late night and early morning rains may be due to the passing of a weather front. Still, it's not 100% correct to assume that morning rain is a sign that the afternoon will be dry. In some cases, a rainstorm that develops in the late afternoon may last up until the night, causing early morning rain. Now, cows could make good weather forecast reporters too. A cow with its tail to the west makes the weather best. A cow with its tail to the east makes the weather least. Thing is, they don't really enjoy it when the wind is blowing right in their faces, so they prefer to stand with their backs to the wind. Winds blowing from the west usually bring good weather, and those blowing from the east, on the contrary, are likely to provide unsettled weather. Voila! I told you, cows are cool. So, should you ever be in a pasture with cows, you will know what weather it will be in the next few hours, even if there's no coverage and you can't use your phone. Now, in case there are no cows, bears, or any other animals that are sensitive to the weather, you can use onions. Yep, you heard that right. Even onions can predict the weather, and these guys actually predict long-term conditions. Here's a nice rhyme. Onion skins very thin, mild weather coming in. Onion skins thick and tough, coming winter cold and rough. Well, seems there's no prediction connected to French fried onion rings though. If you want to hear a scientific explanation for this, sorry, there won't be any. In fact, scientists say such rhymes have stood the test of time for one reason only, and it's our human selective memory. We tend to remember things we've predicted correctly, and if not, we just forget them. Oaks and maples can be helpful, though, due to their ability to curl leaves when the humidity is very high and the wind's blowing strongly. So, when leaves turn their back, 'tis a sign it's going to rain. Turns out to be quite a true saying. There's even a rhyme for it. When the leaves show their undersides, be very sure that rain betides. I know, betides, it's kind of a forced rhyme, but it is a word, it means happens. Okay, time to move on, let's not beat a dead horse, which, by the way, is not a weather predictor. So hey, did you know that you can even use your friends to predict the weather? Our human body is way more multifunctional than you could have imagined. Here's another short rhyme to prove we humans have superpowers. For instance, our body can predict rain. I know ladies by the score whose hair foretells the storm. Long before it begins to pour, their curls take a drooping form. See? I bet you've noticed it many times and maybe even correlated that our hair may act weirdly when the humidity rises. It may expand in length due to humid air, and naturally curly hair may droop. Naturally straight hair, vice versa, may even curl up a bit. If you have blonde hair, you're even more potent at rain forecasting, as it's more sensitive to humidity. On to more precise predictions. Yeah, it's cool to predict the weather, but what about predicting temperature? You can tell the temperature by counting a cricket's chirps. These guys are quite accurate thermometers. When it's warm, they chirp faster. When it's cold, their chirps get slower. Now, here's what you need to do to get the temperature. Count their chirps for 14 seconds, and then add 40 to the resulting number of chirps. Now comes the disclaimer. Crickets only work in Fahrenheit. For Celsius, you'll need to do some extra calculations. While not all weather lores are accurate all the time, they can be a fun way to predict the weather and connect with nature. Meanwhile, my hair is turning frizzy, so I'll grab an umbrella.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega-earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe. You rub your eyes, trying to make sense of everything. Perfect circular holes in the bottom of the ocean floor off the coast of Big Sur in California. You have no idea how this happened, even though you're a marine biologist who's been practicing it for years. You go through some of the old records and find out that these holes have been around since the 90s. In 1999, a ship-mounted sonar conducted a survey and found 5,200 of these pockmarks, or large holes over 500 square miles, on the ocean floor. They look like moon craters underwater. You contact your team and get the robot ready to go down and explore the scene and bring back a few samples. You and the team drive to the coast and hop on the boat. You're sitting inside controlling the robot with a joystick. Your teammate sets the robot in the water and drives it down. Everything seems normal near the surface, but as the robot goes lower, the pockmarks start appearing. A bunch of boats swift past you, making you lose your balance and focus. The robot turns on the flashlight so you can see better. But as it goes lower, the resolution is less crisp. It almost reaches the bottom, and the holes are smooth and nearly perfect circular shapes. Some of these holes that were visible in the sonar reading measure more than 30 feet across and 15 feet deep. You show the rest of your teammates the images, and they're shocked. The robot continues swimming, but there appear to be more holes all around. Many of them are too small for the scanner to capture from above. These microdepressions are steep and have sort of tails going in a certain direction. It's possible that the currents underwater played a role in their shape. Everywhere the robot swims, there are new holes all around. After a couple of hours, the robot goes back to the boat with some samples. You take them back to the lab and study them. The robot clearly captures images of human trash, but the samples don't indicate anything alarming for now. Despite the fact that 1/3 of the pockets are filled with trash, there's still no explanation of how they were formed. It's late at night and the rest of your team heads back home. You're passing out in the lab, still trying to find some answers. You wake up the next day, and while cooking breakfast, you get this idea that maybe these holes are gases venting out, which could be harmful to marine life. You quickly get the robot and sail out to the ocean once more. This time, you didn't even think about calling your teammates. You place the robot in the water and get behind the screen to control it. The robot descends to the bottom of the ocean and does a survey. So far, the holes still seem to be covered with trash. But some of the holes have marine life dwelling inside, like fish and seaweed. After much scanning, it doesn't look like they're producing any bubbles, which means there aren't any gases venting out, but you're determined to find them. After a while, you reach one of those large pockmarks, and the robot starts scanning around. You find some bubbles coming from a source, but the robot can't reach it. It swims around trying to find a spot, but nothing. You bring the robot back to the lab and work on it. You attach some mechanical arms on it that can lift things and move them. You bring the robot back down to the same spot, but the bubbles aren't as frequent as before. You use the arms to move some of the trash and find out that the bubbles are being produced by a group of crabs chilling next to a pile of plastic. Bingo! The bad news is, you still don't have a clue why the microdepressions and pockmarks exist. As you try to control the robot to go back to the surface, an octopus wraps its tentacles around it, pulling the robot down. You struggle with the controls and push it to maximum power, but the suctions of the octopus are too strong to break off. It's a game of tug-of-war with the octopus and your robot. It takes the robot under a pile of trash, thinking it's lunch. But you use the arms to maneuver the robot out and swim back to the surface. You go back to the lab even more confused. The robot has collected more samples for you to study. Your eye is glued to your microscope, trying to figure out what's going on, but nothing. You decide to do a carbon dating test to determine how old these holes are. After a while, you check out the results and are even more stunned than before. They show that the holes are around 400,000 years old, so it's likely that human trash wasn't the cause for all this. You pull many all-nighters trying to figure out the truth. You gather your team once more and hold a small press conference about this. You claim that this may be something we should be extremely worried about, but you still can't tell them more than what you know. With all the brain work put together, you find out that the large pockmarks haven't changed or been active for more than 50,000 years. The newer holes were most likely created by human trash settling in the bottom of the ocean floor. The marine life gathered some of this trash like plastics and discarded fishing gear and created homes for themselves. This is why around 4,500 of the holes are newer and have trash in them. But it still doesn't answer why the holes appeared in the first place. You're back to square one. The only way to see what's really going on is to clear up the trash from underwater and study them. The story makes headlines in the local community and catches the attention of a cleanup crew. You organize a trip to the ocean and begin the extraction of all the trash. Many cleanup boats arrive and everyone drops down a net to collect the trash. You send down the robot once more to make sure the nets are hitting the right spot. As most of the trash is being collected, many marine life animals scramble and try to find a way to escape. Everyone makes sure not to hurt them. After a couple of weeks, all the holes are cleared up from the trash. You do another sonar scan from the surface and can see the holes clearer than before. But you still don't have an answer for this. You do some more research trying to see if any other holes appeared around the world. On the other side of the country is a mysterious blue hole off of Florida's Gulf Coast. You catch the nearest flight to Florida and make an appointment with the scientists in charge of the expedition. Blue holes are underwater sinkholes that open below the seabed. Just like on the surface, the underwater world also has sinkholes. This one is called the Green Banana and is 150 feet below. And the hole is 435 feet deep. You dive with some special gear with the rest of the team to a barren ocean floor, and the hole is right there in front of you, looking like an oasis in the desert. You and the rest of the scientists are surprised by the diverse marine life dwelling within. Some sea turtles swim past you, and even sharks. These ones don't harm humans. Halfway through, you reach a narrow path, which makes it difficult for humans to pass through. But everyone is careful. There are corals, sponges, mollusks around the corner. You collect some samples and go back to the lab. Blue holes in general are richer in nutrients than barren lands and host plenty of unique marine life. They're quite common and don't pose any sort of threat to anyone. After making the connections, you don't think the holes off the coast of California have anything to do with blue holes. The mystery goes on.
If there were cataclysms on Earth every 5 minutes, living conditions on our planet would be almost the same as 4.5 billion years ago. Back then, seas and oceans boiled, lightning struck everywhere, tectonic plates changed their shape, lava flowed from volcanoes, and worse, no internet. The Earth resembled a vast boiling cauldron where life was gradually being created. If it starts to boil again, this cauldron could destroy almost all life on the planet. Consecutive cataclysms. Won't hurt to pretend. Let's imagine, shall we? Good morning! You wake up in a small underground bunker. The seismic sensor indicates that a 7-point earthquake will start in a few minutes. You pack a huge waterproof backpack and go upstairs. The underground bunker is protected from seismic activity. It moves with the ground, so you're safe here. But you need to leave the shelter because supplies are low. Also, yesterday, you picked up a radio signal telling all survivors to go south immediately. The coordinates they gave aren't far from your location. You have to hurry, though, before the landscape changes again. You open the hatch and find yourself in the middle of the desert. The sun is almost invisible beyond the gray sky. The ground is shaking, but you're not afraid. There are no houses or buildings, nothing to fall on you. You keep your balance perfectly, and the earthquake doesn't knock you off your feet. It's like jumping on a trampoline. The only danger is the deep chasms in the ground, but you can easily jump over them. After such an extreme morning warm-up, you decide to have breakfast. You take a tin can out of your backpack. You have a few minutes before the next disaster, so you eat and remember how your great-grandfather told you how all this started. Before all of this, the planet was divided into territories called countries. Millions of people lived in them, and then something terrible happened. The tectonic plates started to move, and the air temperature and atmospheric pressure began to rapidly change. In one day, earthquakes destroyed entire cities. Tsunamis and floods washed away the remaining ruins. Volcanic ash blocked the passage of sunlight. Forest fires destroyed almost all vegetation, and eruptions poisoned the air. Only a few people managed to adapt to such harsh conditions, and you are a lucky duck to be one of them. As you finish your breakfast, you're distracted by another ground tremor. Time to move on. Many people travel around the world alone, as they consider it a safer way of life. Some people form small communes, but no one ever stays in one place for too long. Your whole life is in motion, but you don't panic. One of the main rules during natural disasters is to remain calm, so all survivors have steel nerves and excellent physical training. You run a few miles south and suddenly smell something strange. You put on a gas mask. The earthquake has created a limnic eruption. Natural carbon dioxide is released from the ground to the surface. You feel comfortable in a gas mask, but can't run fast while wearing it. Far up ahead, you see a green forest, a rare place that was not affected by fires. You take off the gas mask and go to the tree to take shelter in the shade from the scorching sun. This green area is rich in vegetation. Colorful flowers, strawberries, and many other berries grow here. But you're concerned. Such fertile land comes from being near volcanoes. It spews underground magma rich in vitamins and minerals, so vegetation grows. You can see a high mountain in the distance. This is the volcano. An underground push occurs again and provokes an eruption. You gather strawberries and run away from this place as far as possible. Lava pours from the volcano's mouth and makes a fire in the forest. You unhook a folding scooter with a motor from your backpack and drive away from the fiery mountain as fast as you can. The sky is covered with volcanic ash, but this is not for long. A strong wind grows with each passing second. You realize a hurricane is moving in your direction. You take out a small shovel and dig a hole in the ground. The soil is dry, but you have enough strength to dig a small ravine in a couple of minutes. You dive into the shelter and cover yourself with a protective tent. The hurricane blows the volcanic ash in different directions, and the air becomes clear again. But the fire doesn't stop. The wind spreads through the forest. You get out of the ravine and put on the gas mask again. There's a lot of smoke around, and it's unbearably hot. You know the hurricane couldn't just appear without any reason. Hurricanes are formed when warm, moist air collides with the sea surface and rises to the sky, so there's water nearby. Great, because you're thirsty and want to cool down. A loud sound erupts behind you. You turn around. A massive wave of water approaches the fire. Without panic, you take your life jacket out of your backpack, remove your gas mask, and put on a diving mask and fins. The wave blows you off your feet, but you don't drown. Over the years of survival, you have learned to swim very well. You grab a passing tree and wait patiently for the flood to be replaced by another natural disaster. For 5 minutes, you sail under a black, stormy sky that sparkles with lightning. Despite the waves, you try to row south. It's getting pretty cold. You finally see the shore, but this is not a land, but ice. A strong wind brought a cold cyclone, which caused a fast temperature change. It's like you're in Antarctica. Snow and blizzards are all around. It's freezing, but you take out a thin space blanket made from foil and walk slowly south. Under your clothes, you put crumpled paper, bubble wrap, pieces of cotton. All this also helps to warm your body. Along the way, you collect several bottles of snow to melt later. Icicles form on your face, and you can't see because of the snowstorm. Suddenly, the snow begins to squish under your feet. The ice melts and turns into water. A hot stream of air blows into your face. You find yourself on hard, dry ground, looking up at the sky, then at your watch. 5 minutes pass, and the sky is again covered with black clouds. You take a metal plate out of your backpack and cover your head with it. A few seconds later, you are hit by heavy rain and hail. Giant balls of ice knock on the metal shield, but you go calmly and even with a smile on your face. The ground becomes wet and loose from icy rocks. When the hail ends, you pull out all the heat-insulating materials from under your clothes and hide them in your backpack. Then you lay out a few long spokes of steel. The spokes are wrapped with copper wire. You connect the spokes to each other, making one long antenna. You stick it in the ground and run away. After the hail from the rain clouds, lightning strikes the ground. More precisely, it hits the lightning rod you've just built. You wait for the storm to end, then take the lightning rod apart and return it to your backpack. An intense heat begins. You drink some melted snow and break your way through the desert. The earth trembles, and your adventure begins again. Earthquakes, carbon dioxide, fires, floods, snowfall, tsunamis, lightning, and again and again and again. With the help of a compass, you continue your journey and reach your goal a few months later. You see a long antenna sticking out of the ground. This is a place mark for entering an underground city. The city is built from dozens of massive bunkers connected to each other by tunnels. The city walls don't allow radiation to pass through, and they don't bend from daily earthquakes. People learn to extract energy from the ground. The Earth's core gives heat. This heat boils water, then steam is formed, and electricity is created at special stations. People get water from underground lakes and rivers. Instead of the sun, ultraviolet lamps are installed everywhere, which provide people and plants with necessary light. Natural disasters happen on Earth every 5 minutes, but humanity still has a lot of space underground. Now, have you ever wondered about the longest time it rained nonstop? Even an hour of rain could be a big deal if you're hanging out in a dry spot like the Atacama Desert in South America. It can set a record for that place. But in super rainy spots like the Amazon rainforest, having 40 days of rain in a row might not even turn heads. Interestingly, we only have rainfall records where people live and keep track. Many towns and cities skip the whole rain data collection thing. Plus, there are so many places on Earth where nobody lives, like rainforests or the open ocean, so our rainfall knowledge is a bit patchy. Now, if we were to talk about records, Hawaii has a couple. People there have some seriously long rainy days, especially on islands where winds come from the mountains. From 1939 to 40, they recorded 331 days in a row with measurable rainfall. If you're a person who likes to watch the rain at home with a cup of tea, this might sound ideal to you. But we need to see the sun at least occasionally. Getting some sun is good for your body and soul. Obviously, you get vitamin D. Just 5 to 15 minutes of sunlight a few times a week can make a real difference. And have you ever heard the phrase sunny disposition? Researchers found that people feel down when there's not much sun around. Sunny days make us happier. Sunshine boosts your serotonin, which fights off bad moods. That sunny serotonin isn't just for your mood, it also helps you sleep. And it's also a heart assistant. When the sun hits your skin, your body releases something called nitric oxide, which chills out your blood pressure. Healthy blood pressure means a healthier heart. Now, go tell that to the people who had to go through 881 consecutive days of rain. Yeah, the record was set almost 3 full years of rain. This happened from 1913 to 1916 in Hononumomaki, Hawaii. It rained like there was no tomorrow because the region is a tropical rainforest. How do clouds make rain? Well, rain happens when damp air goes up into the sky and gets a bit chilly. As this air cools down, tiny water vapor molecules huddle up, forming super small droplets that look like a fluffy cloud team. Now, inside these clouds, things get playful. The air moving around can sometimes make these droplets bump into one another and get bigger. Then they can turn into ice crystals high up in the clouds where it's chilly. These little ice buddies get heavy enough to take a tumble down, melting in the rain on the way to the ground. Now, there isn't just one type of rain. Raindrops can come from all kinds of storms. Thunderstorms show up, make a splash, and then they're out. They can dump a ton of rain in no time. Other storms, like winter storms, are more laid back. They stick around for days and dish out gentle rain or even snow if it's cold enough. Usually, the weather switches between moods. It's nature's way of balancing things out. After stormy weather, the sun comes out, the air dries up, and we get to enjoy some clear skies. But things can get interesting if you're in a place with mountains near the ocean. When moist air hits the mountains, it's forced to climb over them, creating rainfall lasting sometimes for weeks. What if I told you there was a time on Earth when rain fell continuously for 2 million years and completely reshaped the planet's destiny? At the end of the Permian era, around 234 million years ago, I wasn't around then, but I read about it, the Triassic period began, marked by the onset of an extended period of rainfall. This phenomenon is now called the Carnian pluvial event. Well, that's what they decided to call it. Recent studies, supported by evidence, suggest that it didn't reshape the planet in that sense, and that it was triggered by coal combustion. The rain wasn't continuous either. So we just debunked a myth here. Woohoo! Next, we have columnar jointing. This is the fancy term for groove patterns that form in lava flows, sills, dikes, and other rocky stuff. These lava creations come in all shapes and sizes. Most are seen as straight, parallel columns. Some have curves and varying widths. They can be as high as 1,181 inches. I'll save you the math. It's roughly 98 feet. The columns are formed by pressure and the cooling process. As lava becomes cooler, it shrinks and forms cracks. Once a crack starts, the lava moves around. These cracks expand to the surface of the flow. Water sneaks into the cooling lava, making it chill down fast starting from the surface, leaving its mark in those patterns. Devil's Post Pile in California is a must-visit place if you want to see columnar jointing. But hey, they're found all around the world. Let's raise our heads to the sky to see something magical. Fire rainbows, also known as circumhorizontal arcs, look like flames dancing above the clouds. To see these eye-catching arcs, you need a special cloud type called cirrus clouds and the sun at least 58 degrees high in the sky. It's a VIP collaboration between sunlight and clouds. Let's break it down further. Take London, for instance. It's around 51 degrees north. Now, sorry Londoners, no fire rainbows for you. Now we move to deep waters to see underwater crop circles. These are giant circular patterns found in 1995 near the shores of southern Japan. Locals were baffled. They dubbed them mystery circles, as if the ocean had a secret talent for sand art. The mystery was solved in 2011. The unlikely artist turned out to be a tiny pufferfish, just 5 inches long. The researchers found out that males were on a mission, spending a solid 7 to 9 days building their circles by swimming in and out and using their fins to carve valleys into the sandy floor. They decorate the peaks of their creations with bits of shells and corals, turning their sandy canvases into masterpieces. Okay, they don't do it for the sake of art. The curious circles have a purpose. The sandy center of the circle serves as a nest. Male swimming moves mix things up, getting sand particles just where they need to be. When a lady pufferfish swims by, the male twirls and dances, swirling sand around. If she is impressed and thinks he is the one, she lays her eggs in the sandy heart of the circle. There you go, another happy ending. Now let's look at frost flowers. You might have seen thin sheets of ice that look like delicate petals and sometimes pop up from the stems of plants. The ice is about as thick as a credit card. It forms when the weather is cold outside. The soil is damp but not frozen, as well as plant stems. Not all plants produce these frost flowers, and the conditions must be just right. Here's how it happens. The water inside a plant stem gets pulled up from the ground. When it freezes, it expands and cracks the stem vertically. As it hits the chilly air, it turns into ice. As more water gets pulled up through the crack, it keeps pushing out super thin layers of ice. Whether a frost flower looks like a narrow ribbon or a wider one depends on the length of the crack. and the way it curls and shapes itself into these petals is random, or the reason might lie in the difference in friction along the sides of the crack. These frost flowers are unique and delicate, and they don't last long. They melt or just disappear quickly. To spot them, keep an eye out for tall grass, especially in places that don't get mowed much. Pay attention to purple ironweed, blackberries, and wing stems. The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hotspots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder and suddenly the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and… whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city. Kiev. You've been dreaming of getting here for years. Getting out your trusty camera, you start taking pictures of the cathedrals, aviation museum, and the Dnipro River, when, without warning, there's an enormous boom behind you. Turning around, you see something towering in the distance. It looks like a gigantic explosion. Time to leave fast. In June 2020, what the people of Kiev were looking at was an Anvil cloud, a rare storm formation in the sky. Forming when strong air currents carry water vapor upwards, the air expands and spreads out as it hits the bottom of the stratosphere. It pushes the dense cloud into the cool anvil shape you see, and sometimes it even gets to be a mushroom. Anvil clouds produce some of the most dangerous lightning of all storms, one that's called a bolt out of the blue. This lightning strike seems to magically come out of the blue sky with the storm being many miles away. This type of bolt comes from the top of the anvil and can be 10 times more powerful than a typical lightning strike. People got so frightened after witnessing a giant cloud just 60 miles away, thinking something terrible must have happened. The locals had pictures of the large billow on social media before officials could explain what was going on. Authorities managed to calm everyone's fears by informing them it was nothing more than a natural phenomenon, and a beautiful one at that. Before dissipating, these clouds typically stay in one area regardless of how strong the wind is. Touring around the northern tip of Queensland, Australia, way away from those creepy crawlies, it's time to take a break and relax at the beach. Getting comfortable, you notice a great big shadow passes over you, then another, and yet another. Looking up, this weird weather is simply stunning. The clouds are called morning glory, a very rare type of cloud that almost seems to roll across the sky, looking like a massive tube. These clouds can measure up to 600 miles long, even appearing in large groups as well. This phenomenon is the result of an updraft pushing through the cloud, creating a rolling appearance, while moist cooler air at the back causes them to sink downward. Southern India between July and September 2001. People witnessed one of the strangest weather phenomenon in recorded history. The rain was red. What many would have thought to be a typical rainstorm left them shocked. The color was bright enough to stain clothes. There were other colors too, such as green, yellow, brown, and even black. In the middle of a monsoon, red rain started to fall, and did so periodically for several weeks. Researchers have found this unusual rain is stained either by dust or algae, so don't try to catch any on your tongue. Scientists aren't entirely sure how the algae got all the way up there. This does make events like this a little unsettling. Like to take a bubble bath to relax after an exhausting day, but taking too long to fill the bathtub? Problem solved. Head to any coastline after a big storm and take a dip. Foamy tides aren't native to any one place or location. They can be formed anywhere in the world. They're most likely to happen along rocky coastlines, like the coast of San Francisco, Northern Ireland, or the Mululaba, Australia. Each coast has differing conditions forming the sea foams. If you scoop up seawater into a glass and look at it closely, you'll see it's full of tiny particles. Many things like plants, chemicals, and lots of salt and minerals create the perfect formula for foam. When powerful currents and wind mix it all together, we get something that resembles a cappuccino top floating on top of the water. When freezing temperatures hit orchards in Michigan, all kinds of unusual things happen, like ghost apples. No, they're not going to scare you at all. But if you plan on sneaking away one winter to find one, be warned. Everything has to be perfect for this to occur, and it's going to be freezing cold. This is actually a rare weather phenomenon caused by having the apples freeze where they are with rain coating the fruit in a thin layer of ice. The apples then thaw and leak out like applesauce, leaving just the beautiful ice shell behind. The Catatumbo River in Venezuela might be the most electric place in the world, with nearly 300 storm days per year. The lightning storms are so consistent, they're predicted for 3 months in advance. During the wet season in October, you might see 30 lightning flashes in a single minute, a truly shocking experience. With each bolt having the energy to power a single light bulb for 6 months, the impressive display could power all of Venezuela forever. At sunset, strong winds flow around the 3 surrounding mountains, forming storm clouds over the water. As the water droplets of humid air collide with ice crystals from the cold air, it produces the static charges that cause the lightning storms nearly every night. If that wasn't bad enough, some storms have lightning above them as well. Try to take a picture of this one. Jellyfish lightning sprites are electrical discharges high in Earth's atmosphere. They're associated with powerful thunderstorms, but they have nothing to do with rain. These sprites occur 30 to 50 miles up in the sky, in the mesosphere. Artificial lights at night make it a lot harder to see this faint lightning. If you spot one, it'll look tiny, but can be well over 30 miles wide. The red sprites are a type of cold plasma discharge above a thundercloud. They're the balance of the lightning charges between the storm clouds and the ground below. Don't try to find this type of donut at your favorite bakery. It won't be there. Snow donuts are one of the rarest meteorological sights to see, with perfect weather conditions needed just to create them. Found in any snow-covered mountain area, like the Rocky Mountains, the wind, temperature, snow, ice, and moisture have to all work together for us to see these phenomenal rings. A thin layer of wet snow on the ground. Under that layer, ice or powdered snow. Then, a strong enough breeze to roll the donut down a hill, just like a snowball. Once it stops rolling, it can be the size of a baseball or as large as a car tire. It all depends on how strong the wind is. A newly formed snow donut won't stay around for very long, so hurry up with that camera. Watching the sunset over the horizon, the beautiful purples and pink overhead are nothing compared to the 3 suns you see in front of you. Wow, since when did Earth get 3 suns? These phantom stars sometimes appearing beside the sun are called sun dogs. Maybe they're called that because they're kind of dogging the actual sun? Sundogs often appear as colored areas of light at the same height above the horizon as the sun. They're mostly observed on a ring or halo, where ice crystals best reflect the light. There are also moon dogs that appear alongside the moon and are formed by lunar light passing through ice crystals, though these aren't seen nearly as much as their daytime partners. Taking photos in the wild, you finally found the perfect spot to take that dream shot. The crystal clear water, the pines, the mountains, and the flying saucer. Wait, a flying saucer? Oh, aliens are here! You might be thinking this if you saw a saucer-shaped cloud. I'm not even going to try to pronounce their name though. Put that on the screen, please. Wait, just kidding. It's altocumulus lenticularis. Aren't you impressed? These are really just unusual cloud formations over mountaintops. When moist air flows over a mountain, a wave is created if the temperature difference is perfect. As the air passes through the wave, evaporation occurs and a series of these clouds may form into an oval shape. Not aliens at all. Whew! The sky is falling! The sky is falling! Well, people who have experienced these clouds say they look like they're coming down from the sky. Mammatus clouds look like giant white lumpy marshmallows, but it might be hard to toast these ones. These weird fluffy clouds can extend hundreds of miles in any direction, remaining visible for short periods at the bottom of Anvil or other thunderstorm clouds. The strange bubble shapes are formed from turbulence within the storm itself, creating an uneven cloud base and appearing anywhere in the world. Mammatus clouds form when moist air sinks into dry air. The air must be cooler than its surroundings, cooled with ice, or be heavy with water. So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's the reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the 2 reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha! Loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster: park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe? But that long ago, there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot expanding gases. It looked like an extremely hot toxic snow avalanche. With a temperature of about 1300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate. You come to sunny California and go for a hike in the Santa Lucia Mountains. There, you have a strange, unpleasant feeling, as if someone's watching you. You look around, but don't see a single soul. That's when you glance at the tops of distant mountains in front of you, and your heart skips a beat. Up on the peaks, you can see the outline of a giant humanoid figure, arms stretched out with a magnificent full rainbow circling it. This mysterious figure is dressed in all black. You can't make out any facial expressions or detail, but you can see it moving. Then it vanishes right before your eyes. Congrats! You've just witnessed the Dark Watchers, a phenomenon that's been terrifying hikers in the California mountains for over 300 years. Even now, scientists can't give an exact explanation for this mysterious appearance. What we do know is it's completely natural, probably. One theory claims that there are no silhouettes at all. The human brain just thinks up images created by shadows the clouds cast on the mountains. Over the centuries, people share stories about this legend, and their minds begin to show it, building recognizable images. The same can happen to you, like when you see the contours of a human face on a burnt piece of toast, or the shape of a dog in a passing cloud. The most accepted scientific explanation is what's called a Brocken specter. It's when sunlight gets bent by drops of fog or clouds. That explains the rainbow surrounding these figures. As for the shadow, it's only your own being stretched and projected on the mountains before you. After all, these figures usually show up when the sun is behind the witness. Natural or not, the vanishing mysterious figure scared the wits out of you. So you head east and find yourself in the desert. The blazing sun beats down on your back. There's nothing for hundreds of miles around. Hard to believe this dry, lifeless plain was once the bottom of a lake. You notice a long trail in the sand, as if someone was pushing or pulling something really heavy across the ground. You follow the strange trail, and at the end you find a single large stone. But why would anyone drag a heavy rock across the middle of the desert? But nothing touched this stone. It moved by itself. It's a phenomenon called sailing stones. Every winter, ice covers the ground here. When a strong enough wind blows, the stone starts to glide across the slippery surface. Once the ice melts, all that's left is a winding trail behind a single lonesome rock. Well, for some relief from the scorching California sun, we head to Antarctica. Snow, ice, and more blinding sun. Yep, it's a desert too. The light is almost blinding. You squint, and off in the distance, you see something red sticking out from all the surrounding endless white. As you get closer, you realize it's a waterfall, an ominous red cascade flowing from the glacier. Splashes fly in all directions and stain the white snow. Don't worry, these so-called blood falls are nothing of the sort. Millions of years ago, I wasn't around then, a glacier formed over a pond and blocked access to sunlight, heat, and oxygen. Then the pond managed to break through the glacier with a little trickle of water. When such salty water with high levels of iron meets oxygen, it creates that scarlet rust color. This is the only waterfall of its kind in the world. Now, in the town of Taos, New Mexico, locals hear a strange hum every day. But not all of them. For some reason, only about 2% of the residents can hear the sound. Some theories proposed it's caused by the location's unusual acoustics. Others put it down to some strange auditory hallucination or even something more sinister. Unexplainable sounds happen on other worlds as well. In 2020, the Mars rover recorded a strange hum coming from the red planet. It's a quiet, continuous drone that sometimes fluctuates because of Mars quakes. Back on Earth, we head to the warm rainforests of Southeast Asia. You see a tree that looks as if someone poured paint all over it. But the rainbow eucalyptus was painted by nature. Its unusual bark changes colors over time like a kaleidoscope. It starts off as a bright green shade, then red, orange, purple, and finally brown. Then the colorful cycle starts again. One of the biggest mysteries of nature is ball lightning. It's a glowing blue, orange, or yellow sphere that appears during a thunderstorm. Many witnesses say they hear a hissing sound and detect a strong odor with it. The first mention of ball lightning described it breaking through a window and disappearing. As with any mystery, scientists can't explain the exact cause. A popular theory is that ordinary lightning strikes the ground and causes a reaction between oxygen and vaporized soil elements. Ball lightning often occurs during earthquakes, when it usually takes the form of a blue flame coming out of the ground. The ball lightning phenomenon happens all over the world, but so far, no one's been able to snap a picture of it. There's an extremely unusual volcano in Java. If you go there at night, you'll see an electric blue flame burning from the ground, along with oozing bright blue lava. It's incredibly hot, but that's not actually lava. All this unusual blue is sulfur gas escaping from crevices in the volcano and catching on fire. It also condenses into a liquid form and looks like blue lava flowing down. As soon as you come to the Namib Desert, you immediately notice something very strange. Sprinkled among the dry grasslands are almost perfect circles of dirt where nothing grows. These massive polka dots are called fairy circles, and, you guessed it, nobody really knows what causes them. The likely culprit is termites eating the grass around their underground colony. Well, that could explain the circles' differing sizes. The bugs continue to eat as the colony expands outwards, but they stop before they encroach on a neighboring colony. The patches where you do see grass show a sort of boundary separating different termite populations, or so goes the theory. Heading down under to Australia's Lake Hillier. Your eyes don't deceive you. Yes, that lake is bubblegum pink, and is perfectly safe to swim in. The giant pink puddle is a salt lake, and it's not the only one of its kind in the world. Salt lakes are pink because of a kind of algae and other microorganisms living in them. They produce a red pigment to protect themselves from the sun. What's unique about Lake Hillier, though, is the water is still pink even if you scoop it up into a glass, and it remains bright pink all year round. The same can't be said about other pink lakes. Japan is home to one of the most famous active volcanoes in the world. It's special because it creates an incredible natural phenomenon, a dirty thunderstorm. The volcano regularly spews out a black cloud of smoke, ash, and lightning. During an ordinary storm, ice crystals collide with each other and cause discharge, creating lightning. In a dirty thunderstorm, particles of volcanic ash collide instead of ice. A peaceful night on the beach. The waves wash up on the shore and glow neon blue. But it's not the water that's glowing, it's the creatures living in it. This phenomenon is called bioluminescence. Plankton and algae release this glow when waves disturb them. Some fish, squid, and crustaceans can emit neon light as well to lure prey. No time to walk along the shore enjoying the natural light show. Hurry, we're heading out to open sea. There's no storm or wind at all. Which is why it's so surprising when you see a massive wave 5 stories high suddenly sweep across the calm waters. It nearly overturns your boat. But just as soon as it arrives, it vanishes in an instant. What was that? This unpredictable and still unexplained danger is called a rogue wave. One theory of how they form is from the sea's surface encountering a strong headwind. But remember, you didn't feel any wind blowing. Theory number 2, and the most accepted one, different waves combine to form one large one. It's something called kinetic vampirism. Under certain natural conditions, waves accumulate and exchange kinetic energy. Among all the waves, there will be one that absorbs the energy from the others like a vampire. When a lot of energy is accumulated, it releases itself in the form of a giant wave.
In the high altitudes of northern China, there is one mountain that remains frozen all year round. It's a naturally occurring spot of cold earth. A thick layer of permafrost lies underneath the mountain's top layer of soil, freezing everything above it. The climate-defying pocket of frozen land covers over 26 feet of a mountain slope in Pingchuyen County, a place famous for its scorching hot summers, reaching highs of 90 degrees Fahrenheit. This frozen spot of land manages to survive the blazing temperatures due to the coarse blocky layer of soil covering the permafrost. This coarse soil prevents the hot climate from reaching and melting the permafrost, allowing the ground to stay frozen all year round. Argentina may be famous for its beautiful beaches and hot sun, but in southern Argentina, you can find Perito Moreno Glacier. This stunning blue glacier covers over 100 square miles and is constantly growing. When visiting this natural wonder, you might notice an archway of ice forming off the side of the glacier, reaching out to the nearby land. Suddenly, the archway ruptures and the ice collapses into the water below. This is completely natural. The glacier goes through a process of forming these arches until they collapse. It'll form another one in no time. On California's Glass Beach, there's no sand and only colorful gemstone-like pebbles called sea glass. Surprisingly, these beautiful pebbles are the result of garbage. For decades, the beach was used as a massive dumping ground for locals to abandon their glass, appliances, and even cars on the beachfront. The state eventually prohibited anyone from disposing of their garbage on the beach. Over the years, the waves broke down all the remaining junk and turned it into brightly colored pebbles that attract tourists from all over. The highest waterfall in the world, Angel Falls, can be found in southern Venezuela. The water there travels along one of the biggest tabletop mountains in Venezuela and plummets 2,500 feet down into the jungle below. That's 3 times taller than the Eiffel Tower. The water falls from so high that most of it evaporates into mist before even reaching the ground. Visitors can feel the mist settling on their skin from over half a mile away. In Scotland, hidden away from the main roads and tucked deep within the woodlands, is Fiddick Glen. This area looks like something out of an ancient fairy tale, with looming glass moss-covered rock formations and crimson red waters. The water's red color is due to the red sandstone lying beneath the shallow river. To get to this stunning natural beauty, you have to embark on a dangerous hike down steep, muddy hills, clambering onto trees to stop you from falling. But when you reach the bottom, it'll all have been worth it to watch the sunlight shine off the ruby waters and see the towering rocks of this enchanting world. With bubblegum pink water and a surrounding circle of emerald green forests, it's hard to believe that Lake Hillier is a real place. Located in Western Australia, no one can truly explain why the lake has pink color. However, scientists have theorized that the high quantities of salt in the lake have attracted a salt-loving pink bacteria called halobacteria, responsible for the lake's trademark shade. In a small peninsula in South America, there is one of the most beautiful natural wonders in the world, the marble caves. These look like any other caves from the outside. Inside these caves, the walls consist of smooth, swirling blue marble formations. Over thousands of years, water has eroded the marble deposits within these caves, forming this unique cave system. So while deep blue color seems like it's part of the marble, it's the reflection of the water that causes these blue shades along the cave walls. Azerbaijan's mud volcanoes are exactly what they sound like. Over 300 of these natural phenomena are located in Azerbaijan, more than anywhere else in the world. There have been over 200 eruptions since records began. Mud volcanoes are landforms caused by the eruption of mud, water, and gases. Pockets of gas form underground and force their way to the surface, eventually erupting and splattering mud everywhere. These volcanoes can be pretty dangerous. In 2006, a mud volcano erupted in Indonesia and coated an entire nearby village in thick mud. Pamukkale is a marvelous hillside of tiered thermal pools. The name of the Turkish city translates to Cotton Castle. The pools are made of travertine, a type of limestone that gives the hillside its stunning white color. In addition, the stone has geothermal properties, making the pools hot springs. There are 17 pools in total, and all are open to the public 7 days a week. The temperatures range from 95 degrees Fahrenheit all the way to 212 degrees Fahrenheit. They are essentially nature's version of a hot tub. Legend has it that the Giant's Causeway in Northern Ireland was formed when a great Irish giant was challenged to battle a Scottish giant. The causeway was built across the sea so the two giants could meet. When the Irish giant defeated his foe, the Scottish giant ran home and destroyed the causeway behind him. All that remains are the beginnings of the causeway at the water's edge. The stunning rock formation of interlocking columns was the result of an ancient volcanic eruption. The columns are a hexagonal shape and form a natural staircase from the Irish Sea to a foot of a cliff. The tallest columns are 39 feet high. The Giant's Causeway is the most popular tourist destination in Northern Ireland, receiving almost 1 million visitors in 2019. Deep within the Nika mines in Mexico, you can find the Cave of Crystals. The cave is full of massive shards of bright selenite crystals. The largest is 37 feet tall. These are some of the largest natural crystals in the world. It's thought that the water that previously filled the cave was incredibly rich in minerals, allowing the crystals to grow to their full potential. Unfortunately, tourists cannot visit the Cave of Crystals due to its scorching temperature and humid conditions. Even scientists are required to have a special permit to enter the cave. The River of Five Colors is located in the Colombian province of Meta. Known locally as the Rainbow River, the waters are famous for their striking colors. The river is variously colored yellow, green, blue, black, and most prominently red from summer till winter. Due to a lack of nutrients, the river's water is naturally clear, so it's easy to see diverse and colorful plant life on the riverbed. It's these vibrant plants that give the waters its many colors. In New Zealand, you can take a boat ride through the beautiful Waitomo Caves. The walls of the caves glow luminescent, like bright stars against the night sky. But these glowing lights aren't stars, they're worms. Luminescent glowworms live in the walls of the cave, giving the cave its trademark glow. The particular species of glowworms cannot be found anywhere else in the world. For thousands of years, the fairy chimneys have stood tall in Cappadocia, Turkey. These unusual rock formations are tall, thin spires of rock that were initially formed by lava. The tallest chimney is 130 feet high. Humans have hollowed out the insides of these rocks for hundreds of years to create homes for themselves. Today you can visit one of the many hotels that currently exist inside the fairy chimneys. Wave Rock is a popular spot for a photo shoot in Western Australia. The giant rock is 46 feet tall and shaped like a breaking ocean wave. Millions of years of strong winds and hard rainfall eroded the rock into the wave-like shape it has today. The rock has a stunning mix of red and gray colors caused by minerals washed down the rock. The site of the Wave Rock has become a famous camping ground due to its proximity to beautiful lakes and a variety of wildlife. The Zanyi National Geopark in China has previously been voted one of the most beautiful landscapes in the world. The park is famous for its colorful rock formations, popularly known as the Rainbow Mountains. Layers of minerals and different colored sandstone were slowly pushed together across 24 million years to create the stunning landscape.
Something interesting has recently happened in South Dakota. It was all over the internet, so perhaps you already know about it. In July of 2022, the sky in this state suddenly turned green. So, what happened there? Was it caused by a human or by nature? Let's find out. Tuesday, July 5th, 2022. Shortly after a heavy storm, the sky over South Dakota in the US was still overcast. Locals finally went outside and saw that the sky had an intense dark green hue, and they'd never seen anything like that before. People said that it looked like something straight up from science fiction, or even a horror movie. Unsurprisingly, South Dakotans immediately started spreading the news all over social media. People shared their beautiful, yet very eerie pictures on Twitter. They showed the sky over the city of Sioux Falls and a few other towns. Even though it may look like something supernatural, in reality, this is not a terrifying phenomenon at all. It's a simple play of the light and the atmosphere. Something like this happens quite rarely, and usually means that really bad weather is approaching. And that's also true to what happened in South Dakota. Just before people started sharing photos, a thunderstorm swept through the town of Sioux Falls. This was confirmed by the U.S. Weather Service. This hurricane was terrible. The wind speed was about 100 miles per hour. According to the Beaufort scale on wind speeds, this is the fastest and most destructive storm. There are only 12 numbers on this scale, and the maximum wind strength starts at 73 miles per hour. But why isn't this all over the news then? Well, because it's kind of a usual thing for the residents. Thunderstorms occur very often in the United States, especially in the warmer months. And 1 out of 10 such thunderstorms can become something serious, like a tornado. This one wasn't an exception. It was the so-called derecho storm. Derecho is very widespread and long-lived. It's actually a combination of a fast-moving group of severe thunderstorms and downpours. People often say that a derecho is as strong as a tornado. Still, there's a difference between them. A tornado is a vortex, a rotating column of air. It's usually about 500 feet in diameter, although sometimes its width can reach up to 2.5 miles. I don't envy those who would stumble upon that. But the main point is that they rotate. The wind moves very fast in a circle, near some invisible center. A derecho is a strong thunderstorm, or a system of strong thunderstorms with straight-line winds. In other words, it doesn't spin. Instead, the derecho chooses a point somewhere and simply runs to it, like a very motivated marathon runner. If we compare a derecho to an ordinary tornado, the latter has 6 levels of strength, from 40 to 380 miles per hour. So a derecho is kind of like a small, average level 1 to 2 tornado. Usually its speed is within the range of 73 to 113 miles per hour. And in both cases, they can be accompanied by severe thunderstorms, lightning, and rain. But still, these are different things. A storm becomes a derecho if the damage trail left by it exceeds 240 miles, and if the wind speed is at least 58 miles per hour. It's quite difficult to predict. It can form even on a clear day when meteorologists don't even anticipate any storms. And then, the winds appear suddenly. It's so surprising that they may even feel explosive. But the National Weather Service tries to warn people at least half an hour or an hour before this happens, so that residents have time to prepare and hide. It wasn't any different this time. The storm swept through almost all of South Dakota, as well as the states of Minnesota and Iowa. The consequences were quite serious. More than 30,000 people were left without electricity. Fortunately, people were fine. That's because the locals are pretty used to derechos. However, the green sky is something different. It became a very unusual sight for the locals. Everyone was wondering why it happened. Was it a bad sign or a normal weather phenomenon? Well, to be honest, Scientists don't have an exact explanation, but although there are only assumptions, they sound pretty convincing. A green sky is a very rare phenomenon. Most scientists think that this happens when a powerful storm approaches the area before sunset or sunrise. Then the sky will turn green in this area. NBC meteorologist Bill Cairns, who once faced a similar event himself, suggests that the green sky appeared because of the huge hail before the storm. First, let's talk about why the sky looks blue, or any other shade, depending on its mood. In short, the sun simultaneously carries all the rays of the color spectrum. It may seem white to us in total, but it actually has all the colors at the same time. However, these color waves all have different lengths. For example, blue rays are shorter than the other ones. They jump away from the air molecules better than the red waves, so they reach us faster. Because of this, on a regular clear day, the sky seems blue. At the same time, red and orange color waves are very long and move slower, so they're usually left behind. But when the sun goes below the horizon or rises, the rays' directions change, and these waves reach us better. It all means that even if the sunrises and sunsets seem red and orange to us, in fact, there are still blue and green waves among them. But they have to bounce off something to reach us faster and become stronger than the red rays. Have you guessed what I'm getting at? This is where the water comes into play. Clouds are made up of water droplets. When they become large enough, but don't fall yet, for example, due to strong winds, they affect how the light behaves in the sky. Large, heavy storms mostly consist of water and hail, and water reflects blue and green rays best of all. That's exactly the reason why the water in rivers and lakes seems bluish-green to us, although in reality, it's transparent. And yeah, algae matter too. So, there are a couple of key factors why the sky may turn green. First off, the sun should be at the horizon level. Another factor is that while the storm clouds are approaching, they shouldn't cover the sky completely. There still must be a little room for the sun rays. Then, barely noticeable blue rays jump up to storm clouds. They're repelled by water droplets and hail. Mixing with the red sunset, they turn into a bright green light. And this green light is spreading all over the sky. That's why in most of these cases, when the sky turns green, people can only see it in the evenings. Yeah, it can also happen in the middle of the day. But since the conditions are already quite specific, seeing something like that during the day is even rarer. Still, if you see a green sky, you don't need to panic. It doesn't necessarily mean that a terrible storm is approaching. The chances are high though, but still, it's not a rule. It can be just heavy rain or a heavy hail. In other words, if you see a green sky, then you'd better hide, and hide your car. However, if you were lucky enough to see the stunning sky from the comfort of your own home, it's indeed very exciting. If you get a glimpse of something like that, just know that you had a chance to experience something very rare and special. Some people said it was the most incredible thing they had ever seen.